In this lecture video, we're going to learn how to calculate some parameters of probability distributions. We're going to look at the mean, variance, standard deviation, and of course, the expected value. At first glance, these formulas might look a little intimidating, but please allow me to break them down. With a probability distribution, we have a list of x values and their corresponding probabilities, p of x values. To calculate the mean, also called the expected value, we take each x value, multiply it by its corresponding probability, and then add them up for each value of x. To calculate the variance, we'll first find the difference between each x value and the mean and square it, then multiply by the corresponding probability and add those up. And for the standard deviation, it's exactly the same as the variance. We simply finish by taking the square root of the sum. Our round-off rule in this case is the same as we've seen before. We're going to round to one more decimal place and the number of decimal places that are used for the random variable x. So we take the number of decimal places that are present in the x column of the probability distribution and make sure to include one more decimal place when we calculate the mean, variance, and standard deviation. Let's take a look at an example. We're going to find the mean, variance, and standard deviation for this probability distribution. This distribution refers to the number of television sets in a household in the United States. First, we'll calculate the mean. This is the sum of all of the products of each value and its corresponding probability. And we can use the list feature in our calculators to help us out. In order to edit your list, start by pressing the Stat key and then Option 1, and I'll enter our x values into List 1. I'll put the corresponding probability values in List 2. Now I'm going to use List 3 to calculate x times p of x. That is, I want to take each value from List 1 and multiply it by the corresponding value in List 2. I'll do this while typing in the heading area for List 3 so that it applies to the entire list. I'm going to enter List 1 times List 2, and when I press Enter, it will multiply each value from List 1 by the corresponding value from List 2. Those are all the values that we need to add up in order to calculate the mean. I'll also use my calculator to add up all the values in List 3. I can do this by going to Stat, Calculate, One Variable Statistics, entering List 3 for the list, and pressing Calculate. Now that I have the descriptive statistics for List 3, I find that the sum of all of the values in List 3 is 2.75, which is exactly the number we were looking for, the mean for this probability distribution. To summarize what we just did, we put all of our x values into List 1 in our calculator, and we put all of the p of x values into List 2. We then defined List 3 to be x times p of x, or List 1 times List 2. And once List 3 was created, we added up its values, and that total was the mean, 2.75. The mean value for this probability distribution is 2.75. Now let's think through how we can calculate the variance, also using the lists in our calculator. In order to calculate the variance, sigma squared, we need to add up the difference between each data value and the mean squared, multiplied by the corresponding probability. So if we could create a list that had each of these values in it, then we could add up the values in that list to find the variance. We already have the x values in List 1, so let's create our next list to have each x value minus the mean, 2.75 squared, times its corresponding probability. In terms of our lists, we'll have List 4, and this will be equal to our x values found in List 1 minus 2.75 squared times the corresponding probability values in List 2. Heading back to our lists, by clicking Stat, Edit, we can define List 4 to do exactly that. Type parentheses, List 1 minus 2.75 squared times List 2. And when I press Enter, I have all of the values that I need to add up. Heading back to Stat, Calculate, One Variable Statistics, we can now calculate the descriptive statistics for List 4. And we find that the sum of all of the values in list 4 is 1.6475. That is, the total for all the values in list 4 is 1.6475, which is our variance. And from the variance, we can very easily calculate the standard deviation. The standard deviation is the square root of the variance. That is, sigma is equal to the square root of 1.6475, or 1.2835. Now, the last thing to do is to round appropriately. Our x values were given to us with no decimal places, so when we calculate the mean, variance, and standard deviation, we need to round to exactly 1 decimal place. So in summary, we have a mean, mu, equal to 2.3, variance, sigma squared, equal to 1.6, and standard deviation, sigma, equal to 1.3. Now that we know how to calculate these parameters for a probability distribution, we can talk about expected value. We can think of the mean as the expected value, in the sense that it is the average value that we would expect to get if the trials could continue forever, indefinitely. In other words, we can find the expected value by finding the value for the mean, the sum of each data value x times its corresponding probability. Let's take a look at an example. In Maine's Pick 4 lottery game, you get to pay $1 and select a sequence of 4 digits, not including 0. If you select the same sequence of 4 digits that are drawn, you win and collect $5,000. As simple as that. Let's fill in this table to help us calculate the expected value for this game. There are 2 options when we play this game. We can lose and we can win. If we lose, we're simply out the $1 that we paid in the first place. If we win, however, we will get $5,000 back. Consider that we already paid $1, so in total what we've won is $4,999. Now let's calculate the probability of winning and losing. How many different ways can we choose 4 digits numbered 1 through 9? We have 9 options for the first digit, 9 options for the second, third, and fourth, for a total of 6,561 different options. Only one of these options is correct, so the probability of winning is 1 divided by 6,561, and the probability of losing is 6,560 out of 6,561. That is, there are 6,560 ways to lose out of 6,561 options. Now, to calculate the expected value, we need the sum of each data value x times its corresponding probability. So the next row of our table is exactly those products that we need, each x multiplied by p of x. For the first row, we have -1 times 6560 over 6561. This gives us a product of -0.9998. For the second row, we have 4,999 times 1 over 6561 for a product of 0.7621. Adding these 2 values together will give us our expected value. And we find that what we should expect when we play this game is to lose on average 24 cents. We are viewing this game from the lens of the player. Think about viewing this game from the other side. If every player on average is losing 24 cents, then for every person that plays, Maine's Pick 4 lottery is gaining on average 24 cents. Multiplying that by millions of players, I think they're doing okay. That concludes this lecture video on parameters of probability distributions, including the expected value.